Today, let's look at a problem from Carnegie Mellon Informatics and Mathematics competition from the year 2020. 7 cards numbered 1 through 7 lay stacked in a pile in ascending order from top to bottom, 1 on top, 7 on bottom. A shuffle involves picking a random card of 6, not currently on top, and putting it on top. The relative order of all the other cards remains unchanged. Find the probability that after 10 shuffles, 6 is higher in the pile than 3. Let's get a feel for the problem. This is the initial position of the cards. Let's copy that. And we move 6 to the top. Note that only if we pick card number 6 and take it to the top, 6 will come above 3. So the probability of 6 being above 3 after one shuffle is 1 by 6. We can generalize to see that if 3 is above 6 currently, always the probability of 6 being above 3 after one shuffle will be 1 by 6. Let's look at another position where 6 is above 3 already. The probability of 6 being above 3 after one shuffle will be 5 by 6 because the relative position between 3 and 6 changes only if we happen to pick 3 and take it to the top. Let's summarize this. Let Sn be the probability of 6 being higher than 3 after n shuffles, and Sn bar is the probability of 3 being higher than 6 after n shuffles. Of course, S0 is 0 and S0 bar is 1. And we have Sn bar is equal to 1 minus Sn because these two are mutually exclusive events. So we can express Sn like this. Let's look at each of these terms. The first term corresponds to the probability of 3 being above 6 currently. Therefore, the probability that 6 is above 3 after a shuffle is the probability Sn minus 1 bar multiplied by 1 by 6. The second term corresponds to the probability of 6 being above 3 currently. Therefore, the probability of 6 being above 3 after a shuffle is the probability Sn minus 1 multiplied by 5 by 6. Remember that we can express Sn minus 1 bar in terms of Sn minus 1. Simplifying, we get a recurrence equation for Sn. This is what our problem reduces to, a simple recurrence equation with the initial value of S0, and we need to find S10. This is fairly simple. Let's write down these terms. Notice that we can multiply each equation with the increasing power of 2 by 3 and then add all these terms to get this expression. And that's a simple geometric progression. Let's sum it up. We simplify and we get the value of Sn. And S10 would be this value. We can do a quick check to see what will be the value of S1 that comes out to be 1 by 6, which is what we found earlier. Thank you. Hope you enjoyed solving this problem.